Okay, good morning everyone. I'm going to present my paper which is entitled A Tree-Based Mortality Prediction Model of COVID-19 from Routine Blood Samples. This is a collaboration work between the Bina Nusantara University, Pasar Minggu Regional Hospitals, and University of York. Please introduce my colleague, which is me. This is Nunung Nurul Komaria. And Adimas Andi Purwita from Bina Nusantara University, Sri Dani Atas Asri from Pasar Minggu Regional Hospital, and Dimitar Kazakov from University of York, UK. So this is the outline that I'm going to present for today. We start from the introductions and then related work, research method, result and analysis, and then I will conclude with some conclusions and mention my future work. Okay, as the introductions. Coronavirus 2019 is a disease caused by the severe acute respiratory syndrome coronavirus 2, or we often call it SARS-CoV-2 or COVID-19. It is highly infectious and can spread easily through respiratory droplets. There are many ways to predict the severity or mortality of the COVID-19 disease, include demographics, so we can also see the patient demographics, hypoxia, radiographic features such as chest X-ray or CXR, computed tomography, lung CT, and also laboratory biomarkers. So in this study, we use blood biomarkers. This is used to predict the COVID-19 patient mortality. The laboratory result can be easily collected, and this analysis is routinely done for all hospitalized patients. Blood biomarkers are considered objective indicators of the patient's conditions in quantitative ways. So with this kind of data, the machine learning can learn the pattern easily. So the main contributions of our paper consist of reporting the 11 most prominent blood biomarkers that have been confirmed by the physician, analyzing the discovery of 3 different tree-based models and the salient features they have in common. This is several related works that currently being published. Yan et al. In 2020 published a work that conclude the mortality of the COVID-19 patients can be seen through 3 different biomarkers, which is lactic dehydrogenase or LDH, lymphocyte and high sensitive C-reactive protein or HSCRP. In another study, Habu et al. Recently in 2021, they also find that age, gender, and other complications such as diabetes mellitus and hypertension also factors that can predict the mortality. And then another study by Ko et al. In 2020 also found that lower lymphocyte count contribute to the mortality of the COVID-19 patients. Okay, so this is my research method. We start from the first step, which is datasets collections. In the dataset collection, we collected retrospective blood test data from 1,000 patients during the hospitalized in Pasar Minggu Hospital between March up to December 2020. And then we continue with the data pre-processing, which is include imputations. We fill in all the missing value with the latest data that we found from the same patients. And then finally we drop all the invalid data. So we come up with 984 valid data. And then we also apply smooth oversampling to handle the imbalanced data, because in our data sets the number of death is not as high as the number of the patient who are survived. And then we continue with the next step, which is the machine learning. We focus on the tree-based machine learning, which is decision tree, random forest, and XGBoost. And then we continue with the evaluation, result, and analysis. Here we report the top 11 features with their sharp summary, and we also show the tree so it can be evaluated by the doctors. And then we also reported the accuracy and time. This is the result of our evaluations. The first algorithm, this algorithm we train using 70-30 proportion, 70 for training and 30% for the testing data. For the first algorithm, decision tree, we can see here the accuracy, the overall accuracy is 90%. And the execution time is very fast, which is only 3 seconds. And then for the second algorithm, random forest, we can see here the accuracy is a little bit higher, which is 92%, with the execution time is very long. It ran for 10.71 seconds. And then for XGBoost, this is the best one. We can see here the accuracy is 98%, which is almost perfect. If we can see here as well, for each class, they perform very well. And the execution time is also fast, which is only 1.03 seconds. We run all the experiments several times, which is like 20 times, and then we take the average. This is the 11 feature that we found from the 3 different algorithms. From the decision tree, we can see here that urea leading the data, and then followed by the partial oxygen saturations here, and then eosinophil, and then APTT, prothrombin, in the blood. Lead is the erythrocyte sedimentation rate, and then it follows by the other blood biomarkers. The same with the random forest, we can see here urea also leading, and the XGBoost also mentioned the similar result here. With a sharp summary, we can easily interpret the data by reading the graph. For example, here we can see that if the urea level in the blood of the patients is lower, tend to be lower because the blue is low, and then this patient will have a better chance to survive. Class 0 for survive, and class 1 is for death. If the urea level in the blood found to be higher, and then this patient will be most likely to die. So this is our conclusions. We can see several features like urea, partial pressure of oxygens, eosinophil, activated partial thromboplastin time, erythrocyte sedimentation rate, D-dimer, random plasma glucose test, SGUT, SGBT, platelets, lymphocytes, and segmented neutrophil. This whole is the important factors that we found in the blood of the patients that can predict the mortality. We can see here the trend. If the urea level in the blood is increased and the partial pressure of oxygen is decreased, eosinophil is decreased, and then the rest is increased except platelets and lymphocytes, that this patient will have a greater chance to die. We also analyze the tree from the 3 different algorithms. This is from XGBoost. We can see this tree like this, and we can interpret one possible interpretation is like this: the high erythrocyte sedimentation rate, or LED here, and high D-dimer here. I pick it to be high, which is not lower than 1.20, so it goes here. And then it's low platelet count, so low meaning here following this branch. And then we can say that these patients have a higher chance to die with a probability of 0.629, which is the sigmoid function of 0.534. Next, this is the tree from the single decision tree. In the single decision tree, we can interpret this tree like this: if D-dimer of a patient was less than or equal to 1.568 Ug per milliliter here, and then the patient will be more likely to survive here. So the orange box represent the class of survive, and then the blue box represent the class of death. We can see here the trend clearly. See, this is rules of die patients here. The darker the color, the more confidence the model. So, to conclude our work, in this study, we have explored the biomarkers in blood sample datasets, which can be the best predictors in COVID-19 patient mortality. Our result shows that all the algorithm, decision tree, random forest, and XGBoost perform well in the datasets and yielded a valid tree to be examined by the clinicians. All the algorithms used in this study had shown the accuracy above 90% with a training execution time less than 15 seconds. In the future, we can also explore the time dimensions of the data and observe whether the current finding is still valid. In addition to the blood sample data, we plan to also add clinicians' observation report of the patients during the hospitalizations. This report, which also usually created in free text format, can be easily handled by employing some natural language processing method. And this is the reference that we use in these presentations. Thank you very much.